refuge fauna is quite new. We found it in 2017, and we are in the Cordon Formation up in the northern part of WA. And that was the wrong direction. No, good. This stratigraphic scheme sort of puts the Cordon in place in the late Campanian, early Maastrichtian. The column to the right is a time stratigraphic, so we can see we are talking about a very proximal position on the northwest shelf, actually onto the southern Carnarvon platform, where we only have a few of the transgressive faces reaching and accumulating. Nonetheless, the Cordon is deposited at about 100 to 150 meters, so it's still a bit into the actual coast. We go back to Section Hill. This is where we found this, and our main site. In terms of stratigraphy, everything above the red line is late Paleocene in this image, and everything below the red line, the Cretaceous Tertiary boundary by implication, is Maastrichtian in age. And the main site for this particular talk, but not the only one, is this level marked with the red star, and this is an image of the surface, the residual lag of weathered out inoceramid fragments. Going to another site in the same sort of general region, Seaway Creek, we find cross sections, actual profiles, not very common of course in many parts of WA, and we find the inoceramids distributed largely horizontally in this, and this level is one of the particularly rich levels. Some of them are virtually without any inoceramids. If we look closer, I've outlined actual complete specimens. They are preserved in situ, they are compacted and cracked in the compaction, but we assume from lots of discussions based on other places and here that this is actually the life position. These are in situ in life position. And I would point to the scale here. They are fairly big. The biggest is in the order of 75 centimeters. In these cross sections, that would not necessarily indicate the largest size of these inoceramids. So going on to this, based on this, we kind of have this image of a seascape where we have clusters of inoceramids, large inoceramids, sitting on the sea floor, and we have all these ghost faunas that nobody's really found yet, but they would have been there. And what we're talking about today is the sclerobiont communities based on these patches of large articulated platyceramos shells and the fragments of the very same shells. Sclerobiont is everything that grows on something hard. Since this sclerobiont system is based on inoceramids, we would spend a few seconds on that. They are, of course, originally with the skeleton and soft parts. The soft parts, soft tissue, is lost very fast by predation and taphonomy in different kinds of steps that we'll not go into. The minerogenic skeleton is the interesting part in this context, of course, and it is noteworthy that these particular bivalves, they have a bimineralic skeleton. They have an outer prismatic layer that is actually rather impressive when it's breaking down on the surface today, of prismatic calcite that is stable and well preserved, and an inner layer of aragonite. And we have no real idea from this side at least of the thickness proportions of the two parts. The aragonite is lost early diagenesis possibly even in the pre-burial dissolution phase. So taphonomy in diagenesis is important in order to actually find out where can these sclerobionts actually settle. If we have the live inoceramid on the seafloor, like here, they can settle obviously on the upper valve, on the outside, and possibly also in this overhanging where the margin of the valve is lifted somewhat. So that's fine. There's an in vivo settlement, but these platycerums, they die, but the shells stay back, so they will then be available for a post-mortem settlement on both the outside and the inside this time. Whether they settle on the aragonite or the inside of the calcite that was never exposed in vivo, that we cannot be certain of directly, at least by observation. So when they have been then buried in the sediment, they collapse, whether they have been destructed before collapsing or whether they have been left entire, being predated or dying without being crushed. But at this point, of course, new inoceramids will be around, so we start all over again, and other processes are at work. We have re-exposure by infaunal activity or large-scale muscling through the sediment that would re-expose old, dead shell fragments, and they are then available for settlement in a post-mortem, a second phase of a post-mortem community system. So the long and short of it, we end up with a system where there's always live inoceramids and there's always fragments of inoceramids around for settlement. If we go on to that, look at the actual fauna, we have bryozoan epibionts. They are the most dominant in terms of taxonomy. They are mostly very small, but they are not juvenile, they are mature. Most of the species have structures like this, here and here. They are group chambers, meaning that we can tell that they are sexually mature. All scale bars are 200 microns in this image, by the way. Other sclerobionts, there's a whole string of them, and some of them are very impressive. Mostly, the most spectacular, the oysters that we find, Sodoperma perhaps, but serpulates of various sizes, and forams, and calcareous sponges, and brachiopods cementing onto the shell. That would be the epibionts of part of this, like the bryozoans, most bryozoans. Then we have endobionts, the boring elements in this system, and they are barnacles and sponges, dominant. And then we have surface markings. They are eating marks that are traces of radula, that would be a mollusk, or of the regular echinoids, scraping in this particular instance one zooid out of a very, very thinly spread colony. So we have communities, various types of communities. We have associations that are monospecific, and we have associations that are multi-specific. And it turns out that the monospecific, they are either the boring barnacles or oysters, and they are very rarely together with anything else, but they are very prominent, as this would indicate, scaled by 1 centimeter. They are almost exclusive. They are always on the outside of the shells, only on the outside. So we have interpreted those as in vivo part of the community, or in vivo communities. They don't occur together, which is kind of strange, of course. The multi-diversity is, oops, we go back to this. We look at this one, and we have a good example here. This particular fragment has 29 epibionts on it. There's no borings in this particular one, Most of them, by far the most of them, are bryozoans, 22 taxa, and then a little of everything else. Some of them are indicated, but actually there's only 11 specimens pointed to on this. The remaining specimens are way too small to be seen at this scale. So they are really tiny, the majority. The bryozoans, I should point out, are very interesting in that they are the first Cretaceous bryozoans from Australia at all. They are very diverse, more than 55 species. They are related all over the previous Gondwana fragments, South Africa, Madagascar, South America, and India, and most of them are new. Most of them are new genera also, for fairly obvious reasons. Thank you.